Hello, welcome to RC Video Reviews. Thanks for joining me on this follow-up video to the ESC testing I've done. I bought the cheapest ESC I could find on Amazon and I tried to blow it up. And the first time I did succeed, but I overran the ESC. So I bought another cheap ESC from Amazon and I kept within the amperage limits. And that time it didn't blow up. But what we also learned is that it didn't run at a constant 30 amps either. And the spec says it's a continuous 30 amp ESC. So after that test, the next question came up, well, what about a name brand? Will that run at 30 amps? So I bought a ZTW Beatles 30 amp ESC from Amazon, and we're gonna see if that one can sustain 30 amps continuous. Before I get to the testing, I'd just like to extend an invite for you to join me at Patreon. On Patreon, I have a couple of different member levels that give insiders access to inside information about the channel. So I post rough cut footage, inside pictures, news updates that I just don't make available in a public forum. And I also want to remind you that RCVR now has a Discord server. I'll put that link in the video too. So hop over to Discord and join us there to hang out and chat. All right, let's get on with the video. I want to give you guys a little bit more detail because these questions came up in the comments last time. The motor up front is a Detram 3715 890 kV and it's swinging a 16x8 prop. And I know a lot of you are going to be like, what the? But the reason for that is because I'm trying to maintain a constant amperage of 30 amps. I'm also using two 3-cell 5000s in parallel. And again, I get the question, well, too much MAH, that's not a fair test. Well, it's completely not correct. The reason I'm using the excessive capacity is because over the discharge curve of a LiFePO battery, the voltage drops. So by adding milliamp hours, I can keep the voltage more constant. And notice during the test that I will be managing the throttle to keep the amperage at 30. This is an amperage test. It's not a volt test. It's not a battery endurance test. It's nothing but a current test. We're trying to see if the ESC can sustain 30 amps, which is why I'll keep my hand on the control and I'll manage it to 30 amps for the duration of the run. That's what we're after. Regarding the setup, nothing has changed except the ESC. I kept the same silly shroud that I had on last time. It's in the same position. I've got the same batteries that I used last time, same motor, same prop. Everything is the same. The only thing that changed is the ESC. I'm still stuck with this temp gun, so we'll have to make do with that. I apologize I don't have lab gear, but we'll just have to do the best we can. If nothing else, maybe we can get some relative assessments. The only other thing I'm going to do in terms of the test this time is after I get the motor spun up, I'm going to dim the lights and I'm going to change the camera angle and point it at this screen so you can see it during the test. I want you to be able to see what's going on the meter, so when I'm testing it, you see the real-time data the same way I do. All right, you're in the driver's seat with me. That's enough talk. Let's get this thing started. Here's the goal. I'm going to wind it up to 30 amps. I'm going to look for 30 amps on my meter, and I'm going to adjust the dial. The goal is to try and get a long sustained 30 amps out of it. On the first test, I said I was targeting 8 minutes, but because it only ran for something like 77 seconds, I no longer have a time target. Now I'm just going to run it and start a stopwatch. And I'll start the stopwatch at the beginning of the run and I'll turn it off when and if the ESC quits or when my batteries run out. So with that in mind, let's get this test rolling. Interesting. Let me get a timer on this thing, or a temperature gun on it. Oof, that's hot. Yeah, that's hot. I saw 117 at peak, 118, 120, 122, 127. So yeah, 136, there was 136 just a moment ago. It does seem like they'll heat up after the run stops too for some reason. I'm not sure about why, but there's 119. Interesting. So 30 amps sustained, how about that? And this one only ran for 1 minute and 5. The no name, the cheap one, ran for 77 before it started pulsing, but there was a difference. This one didn't completely cut off. You noticed what happened was it kept pulsing. It kept pulsing. It went vroom, vroom, vroom. The other one, the cheap one, completely basically shut off. It went out of sync and the motor was done. And the only way I got it back was turning the power off and waiting for just a little bit and then doing it again. So that's a very interesting outcome. 30 amp ESC. Now TXK Flyer brought up an interesting point. He came in afterwards and he was looking at duty cycle, and it looks like when the MOSFETs go into a fast duty cycle switching for partial throttle, which means they're going on and off a lot faster than if they're at full throttle. If they're at full throttle, they go on and off slower. So they bring less temperature to the table. Well, in that model, the MOSFETs might get hotter. So his suggestion was, what if you ran it at 30 amps at full throttle? And I'm gonna run one more test just to see what happens, but that's actually a really good idea. And what I'm gonna probably do is look for a prop that'll get me as close to 30 amps as I can at full throttle. That's going to be my next test because I'm very curious about that statement on duty cycle on the MOSFETs. So give me just a moment. We're going to reset the timer and we're going to run the test one more time. Okay, there's the timer. I'm going to go ahead and get it started and spool the motor up. All right, only 43 seconds that time. This is fascinating. This is fascinating learning. I'm really shocked. And let's get the temperature real fast. I'll zoom out so you can see the gun. I saw 122, 120. Yeah, that's not like, it's hot, but oh, there's 133. Yeah, see, they warm up after the test. Boy, that's a fascinating outcome. I would have expected more out of a ZTW Beatles 30 amp. Huh, how about that? So 30 amp continuous apparently doesn't mean 30 amp continuous. This is the second ESC in a row that didn't make it. But there is a difference in the outcome because this one started pulsing, and I would consider the motor probably still flyable. I would still fly that plane, although it's telling you, hey, something's wrong. So you'd know that during flight. Okay, next thing I got to do, I've got to prop down. I want to prop down just to see if running at full throttle in close to 30 amps makes any difference at all in the duration on the run. I'll also top off the batteries again just to make sure we're running with a full charge there. So give me a minute, let me switch over the gear. All right, guys, I got my batteries topped off and I switched the prop out and I found out this is not a 16/8. This is a 16/12. I don't know if the camera will pick that up, but yeah, this is a 16/12. So it's a lot of load. This is a big, heavy prop for a little ESC like that. But again, we're trying to draw current. The idea is to see if the ESC will support the current it states that it will support. So now I've got an actual 15/8 prop on this time, and that's confirmed. That is definitely a 15/8. And that's the next biggest prop that I have available. I don't have anything bigger than that without going into the 16. So I'm gonna have to run this test and we'll see what happens. I think two things we'll learn from this. It probably won't hit 30 amps, but I don't know yet. Hopefully it does, but I don't think it will. But if it doesn't, I'm gonna let it run at its peak, and the idea is to turn the throttle all the way up so we can reduce the temperature effect of the rapid MOSFET switching at partial throttle. That's the idea. The ideal scenario will be 30 amps at full throttle. That'd be perfect. If we could get there, that'd be a perfect test. But, well, I mean, as perfect as I can get it without scientific lab grade gear. All right, the ESC has cooled back down. It's back to room temperature, and I can put my hand on there. So, yep, no problem there. That's definitely room temperature, 83 degrees. I'm gonna get my timer ready to go, and we're gonna run this test. Understand that I can't specifically dial in the current on the ESC. Maybe what's warranted is some lab gear that does let me specify the ESC. Maybe I'll look into that. But anyway, for now, this is what we've got, so let's do the best we can with what we've got. The other failure I'll admit in this test setup is this is not perfectly situated the way it will be in an airplane. So there's prop wash. I'm trying to block that prop wash a little bit with my little shroud here, but there is still movement, and the hot air can't escape. In a closed cell EPO foam plane, that hot air has really nowhere to go unless the airflow is really good through the airframe and it goes out through the back, which is what you hope for. And I do have a hole in the front, so I'm trying to simulate the concept of prop wash coming through the front of the plane over the ESC. It's the best I can do. I understand it's not perfect, but hey, what we're after here is trying to keep everything as consistent as possible with the equipment I've got. Let's get the next test underway. Okay, everything looks good there. I'm gonna get the timer started and let's run this test. Again, remember the goal here is to run it as close to full throttle as I can. Hopefully we hit 30 amps, but I don't think we will. And then we'll see how long it runs at full throttle. All right, here we go. I'm gonna start the timer and get the motor moving. All right, man, we got a result. How freaking cool was that? And the temperature reading is coming back, it's saying 85. And it really, I mean, it doesn't feel that hot. It's hot, but it's not blistering my finger. You know what I'm saying? It's not, like I can hold that on there for a few seconds. 1001, 1002, 1003, 1004. That's about it. 4 seconds, I want to take it off. Okay, before I go any further at all, I'm just gonna say right up front, TXK Flyer, you are a madman, dude. So if you guys don't understand what just happened, let me break it down for you. When I did the first test, TXK Flyer went out and said, huh, that's weird, 30 amps, it should do it. So he went out and did some research and he came back and he hit me up in comments and said, hey, I found some stuff on duty cycle. And to sum it up for you, the answer is that when the ESC spins the magnetic field in the can, what's happening is there's switches, those MOSFETs, and there are switches, and they go on and off in what's called pulse width modulation. They go on and off, on and off, on and off. And at a slower throttle setting, in order to maintain the input, the MOSFETs switch a little bit faster. As the RPMs go up, the duty cycle actually gets lower, so the MOSFETs aren't working as hard. You know, you guys remember the first test, I said, let's shoot for 8 minutes. I got 730 at 30 amps. That is, to me, proof positive that he was spot on with that assessment that it had something to do with the MOSFET duty cycle. Here's what I come away with on this test. Number one, the ZTW 30 amp ESC, that's confirmed. I just ran that thing for straight up real close to 30 amps, and I can't even tell you how happy I was to see this setup get 30 amps with that prop. That's awesome, because now I can go back. You know what I'm going to do, right? I'm going to go back and run the other test. So be on the lookout for that video. But anyway, number one, I'm going to confirm that the ZTW does do 30 amp sustain, which is, you know, how many times have you heard me say it? Do what you say you're going to do. This ESC does what it says it's going to do. It delivered me 30 amps. Continuous, sustained, 7.5 minutes, case closed. No arguments, I'm done. On the other one, I do have to now go back and give the other one a fair shot, because that one was shutting down. It actually stayed running a little bit longer than the ZTW at that partial duty cycle. So I'm going to go back and rerun that test. That will be a separate video though. I just got to tell you, TXK Flyer, man, you're a mad scientist. Thanks for coming in, and I hope you guys learned something today, man. That MOSFET switching concept with duty cycle, it's really meaningful. I wasn't really sure that it would matter that much, but it does. It flat out does. The MOSFET duty cycle matters. So if you want to hit your sustained amperage, keep in mind that you do need to do it at full throttle. Hey, I hope you guys enjoyed the video. I hope you learned something today. If you did, please consider hitting that subscribe button, and don't forget to hit the notification bell. Check out my t-shirt store and affiliate links. That's all I've got for today. Take it easy.